Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about resultant forces. So, what exactly are resultant forces? They are basically the overall force acting. So the resultant force is basically the overall force acting. It makes a bit more sense when we look at some examples. So we've got a ball here. It's got 10 newtons pulling it down, 5 newtons pulling it up. Overall, how much is acting? Well, I can redraw the diagram to the following. That's the same as having 5 newtons acting downwards. How did I get that value? I did 10 newtons minus 5, and it gives me 5 newtons acting downwards. So the resultant force is 5 newtons going down. Simple. Right, let's look at another example. Let's look at example 2. We've got a ball here, but now it's got 3 forces acting on it. 2 to the left, 1 to the right. So I can redraw the diagram as shown. So we're going to go to the left, 2 newtons plus 5, I've got 7 newtons to the left. Yeah, and to the right I've got still the 3 newtons. Much more easier to solve now. So 7 newtons to the left, 3 newtons to the right. That is the same as, I can redraw this one again now to the following. Simply 4 newtons to the left. Easy stuff. So the resultant force is 4 newtons. So yes, I can redraw this diagram in a simplified format, and that will be 4 newtons. Very simple stuff. Right, what about one more example? Let's go for this one. Now I've got loads of forces acting, some in the x plane and some in the y plane. Let's try and break down this problem. So I've got 120 going up, 100 going down, so overall I've got 20 going up. So if I have the same object here, it's the same as having 20 newtons going up. Great. Now, what about going to the left or right? So we know to the right I've got 90 plus 10, so this one adds up to 100, and 80 to the right. So I've got 100 to the right, 80 to the left, therefore 100 minus 80, I will get 20. So it's equal to 20 newtons there. Make sure you can see that I've simplified this whole diagram to mean the exact same thing. Right, now to find out the resultant, I've got 20 newtons going up, 20 newtons going this way. I can work out the resultant by putting both forces together. So I know there's 20 newtons going up. I also know there's 20 newtons going over here. To work out the resultant force is obviously, look, think about it, if I'm being pulled upwards and there, I'm going to move along this path over here. So the red is the resultant force. Okay, so how can I work that out? I can use a little bit of Pythagoras from mathematics. So I can work out this value here, the resultant force F. How am I going to do that? It'll be equal to the square root of 20 squared plus 20 squared. Yeah, Pythagoras, yes. So obviously it's the hypotenuse. I'm squaring and adding them together, then square rooting them. So we're going to go for 20 squared plus, so 20 squared plus 20 squared, square root the whole thing, bang, I've got 28.3. So the resultant force F will be equal to 28.3 newtons. Right, that's a little bit harder now, and it's combining your skills from mathematics into physics. Because I used a little bit of Pythagoras to help me at the end. And that's it for resultant forces. Let's scroll down. Let's have a look at our summary. The summary. The resultant force is simply the overall force acting upon an object. To work out the resultant force, you simply add or subtract them from each other in each plane. So you look at the x plane, and you look at the y plane, you find the overall, and then you may have to use Pythagoras to work out the resultant force as well. And that's it for today's session. I shall see you next time in more CeerazzleDazzle Physics. Goodbye.